Hello everyone, welcome to your next class. Today we are going to continue off talking about different machine learning methods. I alluded to reinforcement learning in our last class, kind of saying, it's kind of a new type. It's not exactly there yet because it's new and becoming more and more used. So I think by now we should probably start considering reinforcement learning its own kind of subtype of machine learning, but there is still debate on that. So we're going to spend the rest of this time talking about reinforcement learning because it's a little bit more complex in terms of the process of how it all works. But like at a high level, it's actually quite simple and something related to classical conditioning. If you're familiar with any basic psychology, Pavlov, for instance, and the ringing bell and the dogs. So how reinforcement learning works is actually based around that kind of learning that we got from psychology. So what you're going to learn today is some high-level concepts and definitions of what reinforcement learning is. You're going to see how the reinforcement learning process occurs. I'm going to draw that out as kind of a syntax using like a maze as an example. And then you're going to lastly hear about a couple of use cases where we're using reinforcement learning to solve complex problems. Reinforcement models are really good at are like trying to solve a puzzle or a problem that you can quantify some sort of value to. They can like explore iteratively and learn how to get peak or optimal performance. We usually use reinforcement learning algorithms for our artificial intelligence when we get computers to beat other players at like games like chess or computer games these days. So how reinforcement learning works, I'll give you a very, very brief example. I'm going to sketch it out, but essentially you don't have labels, but you score it. You tell your algorithm that it's doing better when it makes certain random decisions, and over time it starts to say, okay, well I should do that thing all the time because it's the maximum, it's giving me the maximum score every time. So let's just do a quick example from our syntax section here again. I'm just going to erase all this, and we'll look at something else here, okay guys? So with reinforcement learning, one of the best examples I use for reinforcement learning is running of a maze. So I'm just going to draw a very simple maze for you guys, and we're going to show an example of how reinforcement learning works. I want this to have a little bit of a pitfall. We have that there and here, and it goes through up to here. Okay, very simple maze, right guys? How a reinforcement algorithm works is if we want to teach this algorithm to make it through the maze, we will give it a score every time it gets a little bit closer to its goal, which is here, let's say G. And if it makes enough steps, or we can have it just make a bunch of steps and see how long it takes for it to get to goal, and have it learn how to optimize that and reduce the amount of steps it takes. But how reinforcement learning essentially works is that every step that this algorithm takes, we tell it, good or bad in some way, shape, or form. We tell it some sort of performance. And that over time, it'll start to make successive movements. So it goes up first, and then it'll turn right, and it's stuck. It can't do anything. But on another attempt, it'll go left and then can go up. And on this attempt, it did very, very well. So, and then it'll get stuck, I guess, again here. But because this attempt was so much better than this attempt, we reinforce our learning algorithm to say that, okay, do more of this behavior because it seemed to perform better. And if you reinforce this kind of thing over time, you can get an algorithm that can really do complicated behaviors. We call these things reinforcement learning because it's modeled after psychological concepts around reinforcement and classical conditioning. It's like running a maze, basically, right? And so we reward our algorithm in a very similar way. And so over time, as it learns, okay, well, I got more rewarded for one thing over another, it tends to favor those behaviors later on. And we hope that over time that those patterns that it's learning are actually important or representative of important decisions that it's competing against or learning from. Okay? So with that, guys, let's just call it for now. So you learned about what machine learning basically is, and I showed you 3 different types of machine learning approaches. supervised, unsupervised, and reinforcement. And I tried to impress upon you when they're used, how they're used, and why they're important for those specific tasks. There are a bunch of machine learning algorithms related to each of these types. I only showed you one or two, and it's like the most classic simple ones. So there's tons of learning in here, but at least you know how to navigate the space a little bit as we move forward and like do some actual machine learning. So thank you very much, guys, and see you next section.